Thank you everybody for joining us once again. This is Our Ladies Abuja, and we're welcoming you here once again. Thank you so much. So about us, we're a small community of Our Ladies based here in Abuja, Nigeria. The organizers are as follows: myself, Belikisu, I'm a data scientist based here in Abuja. We have Queenet, who is a food technologist. Dean Muhammad, she works in the public health sector. We also have Ifeoma Egboka, she is an epidemiologist. Mabel Ajumobi, Abiodun Ekwenu, both are also epidemiologists. And we have, last but not the least, Insika Udo, who is a big data analyst based here in Abuja. So today we're going to be looking at working smarter with dplyr 1.20 today. So before we move on, I would like to introduce our speaker. We're we're glad you're joining us today. She is Isabella I'm sorry if I'm going to break this. So
Okay.
Velasquez.
Velásquez, yeah.
Oh, okay. So I'm sorry. Just
Yeah.
forgive me for that. Okay. Okay. So she is part of the developer relations team at Posit PBC, where she works at the intersection of programming, communication, and data analysis to help people get the most out of modern data science tools. She's an active contributor to the R community and a strong advocate of open source, focusing on making data workflows more accessible and enjoyable for practitioners. I know this is just a humble introduction. We have known a lot about Isabella, but I believe we're going to know so much about her when we're going to be seeing her really take us through the topic for today. So, Isabella, if you're ready, you can join us now.
Fantastic.
I'll
Well,
stop
thank you.
sharing.
Yeah. Thank you very much. And thank you so much for having me. And thank you so much, everybody, for joining today. So, really excited to chat about a recent update to dplyr, the update to dplyr 1.2.0. And so, I'm putting my link to the slides, and then I will share my screen. Okay, fantastic. If there are any issues, let me know. So, Um, thank you for the introduction. A little bit more about myself. So I actually gave a very similar talk to this a few months ago at Our Lady's Rome, but I got some feedback from that, and hopefully I would love like any additional feedback on how to make this better, because there are so many exciting updates in this latest version of dplyr that we're going to walk through today. I shared the slides in the chat. Here's the link again. And for this go around, I also included some exercises that uses the previous syntax from dplyr and then the solutions using dplyr 1.2.0. Those are available in the GitHub repository. And so if after the session you would like to try out, what you've learned and see how to apply these functions, you can go through those exercises. I hope they're helpful for you. And I will also be talking about several blog posts and different links, and all of those are available at the end of the slide as well. So don't worry if you don't see it right away, like you can always go back to the slides and see them later. But a really quick introduction. So please let me know in the chat if you are familiar with the tidyverse and dplyr, which is one of the packages within the tidyverse. If this is new to you, the tidyverse is an opinionated collection of packages designed for data science, and they're meant to have this underlying structure and design philosophy that makes it so that regardless of which package you're using in the tidyverse, you understand, oh, what sort of syntax I should be using, the sorts of functionality that will exist, the ability to pipe things, as we'll see, the ability to use either the magrittr or the base R pipe to kind of join different verbs together to do whatever it is that you'd like to do in your code. And dplyr sits within the tidyverse. It's one of the many packages available there. But it really is one of like the powerhouse tools because what dplyr is, it's a grammar of data manipulation, providing a set of verbs that help you solve the most common data manipulation challenges. So things like being able to filter, things like arranging and sorting your data set, joining your data set across multiple data frames, and so on. It is a really fantastic package, and we'll focus on some of the functions available in it in a little bit. And importantly, there is a new version of dplyr that came out a few months ago, dplyr 1.2.0. If you go to the tidyverse.org website, there is a blog post written by Davis Vaughn, who is the current maintainer of dplyr. And essentially, what we're going to go through today are just examples of kind of paralleling this blog post. This blog post is really, really fantastic. I highly suggest if you haven't taken a look at it, please go and check it out. And the nice thing about it too is that in addition to explaining the new features that came out in dplyr 1.2.0, Davis also kind of explains like the thinking and the rationale behind them. As we'll see at the very end, there was a lot of thoughtfulness and, you know, a lot of pondering that went through Davis and the team to decide how and why to change things up in dplyr 1.2.0. And so if I had any requests for you for this session, you know, having worked with data for a really long time, I know how when you get familiar with a function, you know, it becomes kind of like your comfort zone. It's very difficult to change, right? And adapt something new. And but that being said, because of all the work and again, and thoughtfulness that went into this package release, I hope that you are able to at least give them a try, see how they feel for you, and then adopt them into your workflows if you find them to be something that's useful. So going back to dplyr more generally, there are a ton of helpful functions. Things like, again, being able to pull out specific rows, being able to count by a variable, and so on. But today, there's only a couple that we're going to focus on. The first one is filter, and the second one is mutate and case one. So beginning with filter, the first really big update for dplyr 1.2.0 is the expansion of the filter family. So if you've never used filter before, this is what it looks like. So what it does is that it picks cases based on their values. So in this statement, I am saying it for whatever data set that I'm providing, I'm saying filter, select the column that's called bill length and then filter, keep the rows that are greater than 45 for this particular column. So if you take a look at the example that we have on the bottom, take a moment to think which rows will remain. Okay, and so these are the ones that correspond with a bill length millimeter of greater than 45. And so those are the ones that we will keep. And so we will have either an output or we can save it to a new object, a data frame that has for all of the species where the bill length millimeter is greater than 45. Filter doesn't have to be just a single variable though. You could also filter based on multiple values. So if you take a look at this, the first condition that we have put within filter is that species is chin strap. And we can see that corresponds to chin strap in the species column. And then the next condition that we have is again, bill length millimeter is greater than 45. And so as you can see here, there are actually two species of Gentoo that have a bill length millimeter greater than 45, but it doesn't match the first condition, which is species is chin strap. And therefore, when we run this operation, we're only going to be keeping these 3 rows where species is chinstrap and bill length is 45. So we had this original data frame, we ran filter on it, we ended up with a data frame with 3 rows remaining. And filter is incredibly powerful. It's probably one of the functions that we have to use almost every single time when we're running dplyr workflows. But we have, the maintainers and the authors saw there are some times that it can be a little bit confusing. So let's walk through those experiences that are addressed in dplyr 1.2.0. So one of them is ambiguous. Even as on that other slide, as I was like trying to explain what filter is, if we take a look at this, we have island equals Torgerson, and island equals Torgerson, right? And it says filter. And, if you're working with a ton of data and things like that, it might cross your mind like, what is this doing again? Are we keeping these rows or are we dropping these rows? Because the word filter is actually a little bit ambiguous, right? We could be filtering in something or we could be filtering out. And so to answer the question, the function filter was actually designed with keeping rows in mind. That being said, there are many times where we have to filter out a row or drop a row. And so people have found ways of doing that. However, they're not very optimized. So here's an example for dropping rows using filter. Let me know if you've ever done something like this. So we have a data set, and in this case, we want to drop rows where island is Torgerson and body mass is greater than 4,000 grams. And so within here, within our filter statement, the first thing you might notice is this exclamation point. And so this is the negation sign. This is saying not something. And then next to it is our conditions. So island is Torgerson and body mass is greater than 4,000. So if you were to try and read this, it says filter not island is Torgerson and body mass is greater than 4,000. So first of all, it's just a little bit complex, right? Like you have to remember where to put that exclamation mark and everything like that. And so if we're running this, the first immediate thought would be, okay, this row, the second to last row that matches these 2 criteria, we're going to drop those rows because we're saying not these things, which is correct. But if you have NA, not a value, in your data frame, and you run a filter statement with this syntax, it's actually going to drop that NA row as well. And so in the end, you have these 3 rows remaining, the ones that didn't match the criteria of island is Torgerson and body mass is greater than 4,000. But you also don't have this one where the value of body mass was actually ambiguous. It's not a number, and therefore, we don't have an explicit statement saying, yes, drop this or no, drop this. And so if you want to keep that row, it's actually going to be, or I'm sorry, if you want to keep that row, it's going to be dropped and might not be what you actually intend. And so if you were to actually write out the statement in such a way where you keep that NA, the body mass is NA row, this is what it would look like, which is actually a little bit complicated as well, right? And as you can imagine, as your logic gets more and more complex, it's easier to accidentally forget something, drop something you didn't mean to, or not drop something you wanted to drop, and so on. And so with dplyr 1.2.0, you can work smarter with a new function that's called a filter out. And rather than constructing that logic where we had an exclamation point and we had the conditions and there were parentheses all over the place, instead, filter out drops the rows where all of these conditions match, and it will keep the NAs because you didn't explicitly say to drop them. And so in this case, here is filter out. And so instead of filter, now we have filter out. And then our conditions again. Island is Tergeson. Body mass grams is greater than 4,000. We can see here there's a single row that matches both of those criteria. And so that's going to be filtered out. It's going to be dropped. And then our remaining data frame now has 4 remaining rows as opposed to just 3. Any questions so far? Okay, if not, let me know. I have like some
No, no
natural breaking
questions
points.
right now.
Okay.
Okay,
Yeah,
no
I'll just
questions
ask
now.
like before all of the demo periods. And so I kind of wanted to briefly show what this looks like in practice because I know that um, I hope the diagrams are helpful. That's a very new tool created by one of my colleagues that I thought was really, really cool. Let me know if it is helpful to visualize these kind of operations that way. And so in the repository that I have linked in the slides, and also contain these slides, I have a folder with exercises where, again, if you want to try your hand at these new functions yourself, please do so. That's what they're there for. And so if, okay, so for example, here we have our setup with dplyr and the Palmer Penguins package. And so if you've never seen the Palmer Penguins package before, we can take a quick look using this glimpse function. And you can see all the different columns, the type of the variable, like factor, double, and then some examples of these variables as well. And we can see there's a few NAs in there and everything like that. And just to quickly get an overview of what the data frame contains, we have these 3 penguin species, Adelie, Chinstrap, and Gentoo. We have these 3 islands, Bisco, Dream, and Turgeson. And then we also have, you know, some penguins are on some islands and other penguins, there's some penguins that are only on a single island, but Adelie lives on all 3. And just some quick summary statistics, right? That there's also some quantitative measures for the penguins as well in terms of their body mass, like we were seeing in the examples. So just making a very small example. Here is an example similar to the one that we saw on the slides, where we have species, islands, and body mass, and one of the rows is actually NA, and therefore it doesn't actually have a value. And so if our task is to drop rows where both island is Tergeson, right, and the body mass is greater than 4,000, right, we can imagine this should be the row that's dropped. Rows where either condition is NA should be kept. And so this is kind of what we want to go for. But if we were to run, oh, actually, this is like the correct way of running it in using filter, which again uses this complex logic with exclamation marks and statements and so on. So if you've never seen this before, it's saying island is Tergeson and is not an NA in the island column, body mass is greater than 4,000 and is not NA in the body mass grams column. And then all of that, not anything that matches all of these criteria. So again, doable, very complicated. Take a moment and think how you would write this using the new filter out statement. Let's give it a few seconds. Okay, so here we have the data frame. We're using a pipe. Again, what a pipe does is it chains different commands within your using your data, which is one of the great features of using tidyverse packages with the pipe. And so here I'm saying take penguin small, pipe in the filter out function. And then within filter out, I'm going to put the conditions of the data that I want to drop. And so, I think there's someone who is unmuted. And so if I run this, there we go. So rather than writing all of this, what I just do is write penguin small, which is the data, pipe it into filter out, and then put in the condition of what I want to drop, like I don't want it anymore, and then I get this result. And it doesn't drop the one that has NA in the column because I never explicitly said, please drop this. So, all right, let me know if there are any questions about filter out, but it is a very handy function. And I also want to give some tips as to like, as you're writing your R code, if you're ever wondering like, should I be using something else? Here's some quick tips. So if you walk away remembering anything, the first thing is use filter to keep rows, use filter out to drop rows. So if you ever find yourself using a filter and then you're using an exclamation point within your filter statement, take a pause and think, oh, maybe I should use filter out instead. Chat. So Kenneth has a great question. Do we have the filter in alternative or does the old filter do that job? Yes, the old filter does that job. So the two parallels is filter and filter out. I think there's probably a discussion as to whether to explicitly call filter in, but I imagine like the team didn't want to disrupt old code too much by doing that. So, yep. Filter versus filter out. It's a great question. All right. So another issue that you may have run into whenever you're using filter statements is the or operator, this long pipe that is at the end of the sentence here. So for example, let's say that we want to keep rows where Adelaide penguins from Turgeson have a body mass over 3,700 grams, in which case that corresponds to these two rows. So Turgeson and over the 3,700, or where Gentoo penguins have body mass over 5,000. And that corresponds to these two rows. And so if we were to run this statement on our data, those 4 rows are going to be meet the criteria. The filter keeps rows, right? And so those 4 will be kept into our new data frame or a new object or anything like that. And this works perfectly fine, but you may notice that, yes, the old filter is filter in, but just not called that. And so I'm sorry. So this like works perfectly fine, but it can get very, very confusing when you're using this operator and your logic gets more and more complex. And so a new rule of thumb is if you find yourself using the or operator in filter statements, you can instead work smarter with these 2 new functions, when any and when all. So when any is meant to cleanly express or logic. So it will keep any row that matches the conditions, like at least one of the conditions there. So here, instead of what we had before, here we have filter when any species is Adelaide. In that case, these 2, or body mass is greater than 5,000. And running this, we get to keep these 3 rows. And so instead of using that long pipe for or, instead we can use when any. And this is a very simple example, but again, this becomes much more powerful when the logic it gets more and more complex. So for example, here we have when any, two when any statements. And so this is saying filter or keep any rows when either species is Adelaide and island is Turgeson and body mass is greater than 3,700, which corresponds to these two rows, or when species is Gentoo and body mass is 5,000, which is these two rows. And so as you're imagining, you're bundling these different conditions and you're saying keep either like if it matches that first condition, which is highlighted in blue, or it keeps that second condition, which is highlighted in orange. In this case, it's going to keep those 4 rows. And so hopefully this looks a lot more cleaner than using like the pipe for or statements. You can just use commas to separate your conditions and then wrap your separate conditions up in parentheses. There's also another new function called when all, which when any works for or conditions, when all is for and conditions. So this keeps only rows matching all of the conditions. And so here we're saying filter or keep when species is Gentoo and body mass is greater than 5,000. And so when we run this, we will keep only these 2 rows, even though there are other Gentoo penguins. But you may be looking at this and being like, wait a second, why do I need when all? In fact, you can run this statement with filter and no when all, just species equals Gentoo, comma, body mass grams is greater than 5,000, and it will give you the same exact result, which is absolutely fair. But I think the real power of when all shows up when you're also combining it with when any. So when you're able to now nest when all inside when any for this kind of complex logic. So if you recall before, we had a lot of and statements within when any. They can all be replaced with when all instead. So here what we're saying is for our data set, keep any rows when either species is Adelaide and island is Turgeson and body mass is greater than 3,700, or when species is Gentoo, body mass is greater than 5,000. And so it's going to keep those 4 rows, and then that's what we have in the result. And so again, similar to filter out, absolutely doable in many other ways. And you can use, the long pipe for or, the and for and, but these functions are meant to help you write your code in a way that hopefully when you come back to it, it's very readable. You're not like lining up parentheses and being like, wait, what is my condition again? You're not getting confused with all the and the pipes and everything like that. So really that's the goal of doing that, like to increase the readability of your code. And so to quickly show what this looks like. Okay. So now we have from the penguins data set, keep the rows where species is Adelaide or body mass is greater than 5,000. And so if you imagine, here's a quick rundown of how many we expect. We expect 152 rows from Adelaide, 61 body mass greater than 5,000 and not Adelaide. So we would expect a final data set of those 2 put together. And so here we have the statement where we take the penguins data set. We say filter, which means keep, species is Adelaide or body mass is greater than 5,000. And then select certain columns so that it's easier for us to look at. And so if I run this, here we go. And we could do a quick check. Indeed, the species is Adelaide. And then probably if we go towards the end, we'll see body mass is greater than 5,000. So our filter worked as expected. But as a introduction to when any, try and imagine how this would be written with that new when any function. And this is what it looks like now. Essentially, anything with a pipe is replaced with when any, and conditions are separated by commas. So we could do when any, species, Italy, and body mass G is greater than 5,000. And then again, we could do that select statement just to make it easier to read. And there we go. We have the same result, but hopefully, remembering when any within this is a little bit easier than, again, using the pipe. And then what really helps is when we have slightly more complex filtering. So here's another example, just like a smaller data set, so it's easier for us to read. And our task is to keep rows where species is Adelaide and island is Turgeson and body mass is greater than 3,700, or species is Gentoo and body mass is greater than 5,000. So this ends up being our expected result. And so here is the way of doing it before dplyr 1.2.0, which again, perfectly valid. But as you can see, there's a lot of and statements here. There's this the or pipe. There are parentheses here and here. And so the hope is that this provides another option for you that hopefully makes your code a little bit more readable. Try and think about how you would add or how you would filter this using when any and when all. And so again, anything with a pipe can be replaced with a comma and when any. And then statements like this, with multiple and statements, the and sign can be replaced with commas and then wrapped in when all. And so to show what that looks like, so let's write the when all statements, which would be species is Adelaide, island is Turgeson, and body mass is 3,700. Then separating these with a comma for when any later. Species is Gentoo. Body mass is greater than 5,000. And then because we want either this statement or this statement, here's when we put the when any. And so running that gives us our result. So again, two different ways, but new functions that, if they work for you, can hopefully make writing and reading your code a little bit easier. Oops, sorry. There we go. All right. With that, I will just wrap up the when any and when all to kind of just reiterate what I just said. Again, here are some rules of thumb in case they're helpful for you. If you're using any or logic in your filter statement, consider using when any. And if you're using any and statements in your filter statements, use when all. And so if you, again, are just finding yourself writing something that's so complex and has so many parentheses and statements and or statements, just think back and see like if rewriting them with when any or when all makes it a little bit easier. All right. So that was a lot about filter. Now we're going to shift gears a little bit and talk about another function. And the section in the blog post is called Recoding Nirvana, which I thought was a very clever heading. But to begin, we're going to start with a quick review of mutate. And so if you have never used mutate before, what it does, it adds new new columns or modifies existing columns. And whether it adds or modifies depends on whether the column name that you are using already exists in your data frame or not. So here we have an example with just 3 columns: species, island, and body mass grams. And our mutate statement is saying, take body mass grams divided by 1,000 and put the output in a new column called body mass kilograms. And so if we were to run that on our data, now we have a new data frame with 4 columns instead, with body mass kilograms being our new addition. And we can see that it is, in fact, body mass grams. It's based on body mass grams, but divided by 1,000. And mutate statements can get more and more complex depending on what you need. And so there is another way of creating new columns based on conditions called case when. So you use mutate and case when together to evaluate different conditions and then create a new column based on the results. So here, for example, we have that same data frame, but now we're going to create a new column called size category. And to read through the case when statement, what it is saying is, when body mass gram is greater than 4,500, call size category large. And when body mass grams is less than 4,500, call it small. And so if we were to run this, we would get a new data frame or a new object with a new column called size category. And here we can see, yes, indeed, the ones that had a body mass greater than 4,500 now have small under size category, and the ones that had a body mass greater than 4,500 now has large under size category. So that's how case when works. It looks at the rows, it evaluates based on a criteria, and then creates a new column based on whatever logic that you gave the case when statement. Something to note is if there is a column that does not match your criteria. So in this case, for example, we say body mass greater than 4,500 is large, body mass less than 3,800 is small, but we actually don't have any criteria for body mass equals to 3,800 or body mass equals 4,500, so they are unmatched. What case when defaults to is giving you an NA in your data, and therefore it's not a number. And this is on purpose because, first of all, R doesn't know what you would want it to be. And, but it is something, at least for me, when I was starting off as an analyst, would catch me a lot, right? Because I thought, oh, I covered all of the different conditions. In fact, I did not. And so there is something, And so this is the 2 NAs that result from having unmatched rows in your conditions. In case when there is a default parameter, and so this allows you to provide a value, a default value for whenever you have a row that is unmatched. And so in this case, again, we have body mass greater than 4,500 is large, body mass greater than 3,800 is small. And what default equals medium means is anything that isn't caught by either of these 2 conditions, just give it the size medium. And so if we were to do that, you can see, yes, indeed, we have a data frame with medium under size category for these two rows that didn't have any single matches, um, which is great. But it's something to note, right, is that it might give, if there were a third secret condition that the rows were not matching, it's going to default to medium no matter what if it's not unmatched, which may or may not be your desired outcome. So that's another, I think, big catch that happens when writing case one statements. And so other kind of issues that can happen with case one as you're writing them is actually case one was not meant to recode values. And so previously in our example, we were saying, the body mass greater than a number, less than a number. And those are okay. Like that was the initial intention for case one. But people started using case one to recode values instead. And so what that means is if you've ever written a case one statement where you have these two equal signs, what you're actually doing is recoding. So kind of to read through this, what we're saying is create a column called island location when if island is Bisco, recode the new column as southwest. When island is dream, call it northwest. And when island, I have two northwest, is Turgeson, also call it northwest. And so in this case, that equals and these kind of conditions absolutely works, right? We get a data frame that gives us the results that we expected. But this was not the initial intention behind using case one. And one of the ways that you can kind of know that is this equal syntax. It's it's difficult to remember, right? And you're also saying like this character equals a character, like you're actually like saying that it is a condition when in fact, we're not talking about quantitative values and things like that. And so not saying that it doesn't work, but that, oh, sorry, one sec, that there are maybe better ways of doing it. But as we can see, totally works as expected. That being said, if you find yourself writing case one statements with those equal signs, maybe consider using a new function that was designed specifically for recoding values, which is called recode values. And so as opposed to working with conditions like we did with case one, recode values matches exact values and then recodes them to new values. And so what you can see that instead of having all of that island equals Bisco's, island equals dream, island equals Turgeson, all of that is instead dropped because it knows that we're talking about island here. And it's saying, and instead of those equal signs, now we're using the squiggly sign, which is also consistent with how case one works as well. And so here we're saying create a new column called island location. And for what it's doing is recoding the values from the island column. And Viscose is going to be southwest. Dream is going to be northwest. Turgeson is going to be northwest as well. And then run that. And then we get our new column with the values that we expected to be recoded, which is great. And again, it's just meant to be like a better way of writing these kind of statements instead of like forcing a function that wasn't originally designed to do that. Now we have a dedicated function for exactly that. As I mentioned earlier, there is this potential issue that could come up whenever we are writing these kind of statements where if we set a default value, which is great, but we might accidentally be giving a default value to something that we didn't think about when we were writing these conditions. And so in dplyr 1.2.0, there's this new operation called, new argument called unmatched. And you can give different uh, sort of signals to unmatched, and probably the one that I find the most helpful is unmatched equals error. And so what this says is if there is something that doesn't match the condition that you have given it, it's just going to stop. So for example, here recode values, Viscose is southwest, Dream is northwest, Turgeson is northwest, but now we have this secret unknown value, and that's not included in our statement at all. Without unmatched equals error, it would result in an NA, right? Because it is an unmatched row. But with unmatched is error, right? Because it doesn't know, the R console is going to very helpfully give us an error that says, hey, this is not matched. It needs to be matched for me to continue this. And this is just a really great way of being really intentional with your statements so that you're not caught off guard by accidentally giving something that you didn't mean to. If Hmm, I see that we have a question. If we use case when or recode values, which is faster? I actually don't know. That's a great question. Um, but one of the great things about recode values that I'm about to mention is not in terms of speed, but just in terms of functionality. What if you have a huge list, and like you have many, many things that you need to recode, different values that you need to recode? What recode values allows you to do is use a lookup table. And so this means you can have one table with all of the values that you want to recode. You have your data frame, and then to do it in a recode values, you write this from statement, and you say from your lookup table, what column do you want to pull values from? And then to argument, which is from your lookup table, what do you want to change your values to? So if you imagine we have a lookup table that says from and then all of the islands and to all of the directions. And then we have our data frame that has our species, island, and body mass. Here we're saying for Viscose, from Viscose to Southwest for these two rows that correspond in the data frame, from Dream to Northwest, and from Adelaide, I'm sorry, from Turgeson to Northwest, and that corresponds to this one row. And then if we run it, we get this statement. Like, so, I'm using small examples here, but imagine you had thousands of values that you want to recode rather than having to write a really, really long recode value statement. All you need is a lookup table and then just refer to that lookup table in your recode values statement. So I wish I knew if it was fast or not. So it would be, but hopefully this makes it a lot easier if you are working with a lot of data. Hassan asks, so an island being Bisco Fu would throw an error as well. So it would throw an error. Oh, can I go back? It would throw an error if you have unmatched equals error as an argument in your recode value statement. Yes, because it wouldn't, because it doesn't have an exact match, it doesn't know what to do. And so without unmatched equals error, it's just going to default to an NA. But with unmatched equals error, it'll give you uh, this statement, like, which lets you know, like, hey, I'm not going to continue because there was an error. There's another question. Recode values works with a simple real uh, level one. Pedro, you might happy to follow up, but not exactly sure. Works with a simple relation or can be more complex. Level one to recoded level. So So for example, if it were level 1 to recoded level, like here would be level 1, here would be recoded level. Let me know if that's what you mean.
Yes. I mean, it can take more labels for the same recoded label.
More labels. I think so. Mutate creates one column based on your either conditions with case when or your values with recode values. And so I don't think it would be able to create more than one based on that. Yes, if we want to recode level 1 and level 2 in A, we need 2 instructions. Oh, I think I see what you mean. Like within here, like can I write like uh Dream or Turgeson is northwest? We can try it out because I have some code that we could write. That's a great question. Let's do it. Okay, so I think I accidentally skipped that, but here is an example with what we were just looking at. What we want to do is, and just to confirm, I have 37 more minutes, right? Not, it'll go much faster. Okay, let me know in the chat. But in this case, like, sorry?
Okay. Do you mean the
Okay.
time duration for this session?
Yes.
Sorry, I think it's really. I think we have up to 2 hours, but it depends on. It can be 1 hour or more.
Okay. Okay. Um, great. So we can walk through this example then. So say we have this data frame that we were just looking at, and what we want to do is add southwest, northwest, or northwest according to this mapping. So Pisco southwest, Dream, Turgeson southwest. So this is the example that I just showed, or sorry, this is an example using case when, which again, totally works, but is very redundant. Island equals equals needs to be written 3 times. And it's again, just not the way that case one was envisioned. So if you ever see yourself using equal equals, consider using recode values instead. And so what we can do, so just show what it looks like, right? Within our mutate statement, we're going to create a new I keep wanting to write my name. A new column called island location, which is based on island, which is going to recode the values in island to be Bisco is southwest. Sorry. Dream is northwest. And Turgerson is northwest. So hopefully you can see it's a bit shorter, hopefully a bit easier to read, and so on. Okay, so I believe the question was asking, can we put multiple statements within here? Let's try it. I've actually not tried it. So let's say instead we're saying recode values, Bisco's is southwest, Dream or Turgeson is northwest. I wonder what will happen. Oh yeah, it seems. Oh, well, no, it didn't.
For me.
It didn't do it, right? Because yeah, it marked those two as, oh, because I see. Oop. Anybody else see the issue? What it does is it reads this as a whole thing. And so it's looking for something that looks exactly like this dream pipe Turgeson. And so because it doesn't match, it produces an NA. That's a really great question. I don't know if we can do multiple statements within this or if it requires each value to be a separate row. I really appreciate the question. If anybody thinks of a solution, let me know. Because I think this will not work. Yeah, no, it is not like that at all. Instead, a tree like this. I imagine too, like forcing everything to be in a single line also like forces us to be explicit, which is, generally a positive something, but hey, that worked. Thank you for the suggestion.
Very nice.
Yeah.
Thanks.
But I would definitely say this is probably not ideal, as you can imagine. It probably get very messy very fast. So if at all possible, what I would suggest is using a lookup table for anything that's, particularly long or complex. And just to give an example of a lookup table, here's Penguin Islands again. And now we're creating a new lookup table called Island Lookup, which is just those 3 rows with a from column and a to column. And so just to rewrite it using recode values, I think I have both. What we would do is Penguin Islands and then mutate. And then again, the name of the column that we want to create, the column that we are referring to, recode values, and then here from equals island, look up, and then from to equals island, look up to. So that's referring to this table here, and running that also gives us the same result. As you can imagine, if this were very, very long, this is way, way easier to write. Cool. All right. So in terms of the final things, oops. Yeah, there we go. Just again, to go back to our rule of thumbs about when to use recode values, whenever you're using, or whenever you are creating a new column or modifying a column based on conditions like greater than, less than, and so on, you want to use case when. Whenever you're adding or modifying a column based on values for exact matches, then you use recode values. And basically, if you catch yourself using equals in case when, consider using recode values instead. So another there are actually several new functions in this family. Originally, there was only case when. Now there's recode values, and there's a third one called replace values. And so what replace value does is, if you recall, earlier we said whenever we're using case when and there are rows that we don't necessarily want to modify, we want to either leave them as they are, then we still have to provide something in the condition. Otherwise, it's going to result in an NA. And so, as you can imagine, this is very tedious. And one way of going around it is you can use this default and say like default equals and then that name of the column. And so it would refer back to the same value that's already in that column. But there might be times where all you want to do is replace specific rows with something, and that's it. And you shouldn't have to write a whole case when or recode values statement for that. So there is a new function called replace value. So what this is saying is for island location, which in this case already exists, it's a column in our data frame, replace the values that say northwest with northern Palmer arpeggio. And so if we do that, these are the two columns that match that condition. And we run the statement, and here we go. Only those two rows have now been changed. The ones that match with island location southwest were not touched. And so we didn't have to define any kind of default argument because that's what replace values is for. So basically, if you're ever touching only some of your data frame, use replace instead. And replace values is, parallel to recode values. So in this example, we're saying this is a exact match, right? Northwest is northern Palmer arpeggio. There's also a new function called replace when, which parallels case when. So again, when you want to replace only some of the columns, or I'm sorry, only some of the rows in your data frame based on a condition. Just like case when is for condition, replace when is for condition. But once again, you don't need to do a default. So in this case, we're saying for body mass grams, when body mass gram is greater than 5,000, which corresponds to these two rows, make it 5,000 exactly. And so because it's a condition, that's why we're using replace when. And when we run it, only those two were touched. So again, the nice thing about this is we don't have to say default, body mass grams less than or equal to 5,000, make it body mass grams or anything like that. And we don't risk accidentally introducing an A's in our data frame because we're being very explicit about what exactly we want to replace. So just some rules of thumb in terms of when to use replace. If you want to create or modify, create a whole new column, you'll want to use case when and recode values. But if you want to modify only some rows in an existing column, that's where you're going to use replace instead. And so if you are finding yourself having to think really hard about that default argument and what you put in it and everything like that, consider using replace instead of replace values for recode values or replace when for case when. And I think I actually have an example for that too. Okay. So in this case, we have, again, that data frame with the species, the island, the body mass, and the island location. What we want to do is replace this northwest with northern Palmer arpeggio and leave southwest unchanged. So this is our expected result. This is how we could do it using case when and mutate, which again, we don't want to do for multiple reasons now. First of all, this means that we're using this syntax, which we don't need. Oh, sorry. This syntax that we don't need to use. And then we also have to define a default. Instead, what we can do is we could do penguins locations, mutate island location equals island location because we're keeping the same column. And then here we're saying replace values and the exact values that we want to replace. Northwest is northern Palmer, keep go. And so hopefully you can see the differences between using these two. We get the same exact result, but hopefully this is a lot easier to read. And again, it's really just about the complexity of your code and your tolerance for, potential errors and unintended consequences that happen as you're making very, very complex logic statements. there are more exercises here. I hope it all is helpful for you as you're practicing these new functions as well. Awesome. All right, just to begin to wrap up, a few things to note. If you've ever been using case match, which has been around, I think since dplyr 1.0.0, or 1.1.0, it has been soft deprecated in favor of these new replace functions. And so what that means is that over time, it's going to not be maintained anymore. And so if you find yourself very heavily leaning on case match, now would be a good time to start practicing these new functions before it's no longer supported in dplyr. Another thing to note is there were actually a ton of changes in dplyr 1.2.0 that don't have to do with the code itself whatsoever. One of the big ones is that, or how you write your code, what I mean. It had a huge boost in speed. And I know somebody asked about speed earlier. Hopefully, if you've upgraded to dplyr 1.2.0, you've seen a really big change in how fast it has gotten. This is particularly helpful if you rely on these functions for developing packages or anything like that. But in general, all of the great work that the team has done, impacts everybody, even if you're not a package maintainer. So we, can leverage AI and LLMs to help us write our code, but large language models have like a certain cutoff point for their knowledge. And so I would definitely say, as I use it, I can definitely tell that they haven't caught up with dplyr 1.2.0 yet. And therefore that means if you ask Claude Code or whatnot, hey, write me some code, it might default to an older version of dplyr that doesn't know filter out, replace when, recode values, and so on. And so if you want your large language model to know the latest and greatest, there are a few things that you can do. Probably the least scalable is like pasting documentation into the conversation. Like you could tell Cloud Code, hey, read this blog post from Davis and give it the URL. And, it can use that to write code for you for that particular project or your global, that particular project. But the issue with that is that means you have to remember to do that every single time you start a project with Cloud Code. If you are a bit familiar with these large language models and their tools, there are also things called Claude MD or skills that which are markdown files that you can add to your project or your global setting so that it knows to use like these directions that you have for it anytime that you start a project. So this Claude MD file can have, or the skill file can say something like, hey, anytime that you're writing R code, please go ahead and use dplyr 1.2.0. Here's the documentation or something like that. I realize I have the same point twice. You can also point it to the docs. One downside to Claude MD or skill files is that because they are just markdown files that live on your computer or whatnot, that means they will get outdated at some point, right? When dplyr 1.3 comes out. And so if you are very familiar with using Model Context Protocol Server or MCP server, that is another way that you can ensure that your code is always using the latest and greatest from dplyr or any of the tidyverse. The last point I kind of wanted to hit is that community feedback is so important and was absolutely vital in, the development of dplyr 1.2.0. Davis, for example, is very active on social, and this is his post on Blue Sky where he, actively said, hey, we're looking for feedback on these new functions. And I know that there was a discussion about using filter in. I'm almost certain that there was a discussion point about should we call it filter in or should we just leave it as filter? That was discussed. And so all this to say, like, depending on like the tools that you use, like you are fundamental in improving them and making them better. In addition to social media, the Tidyverse team maintains a repository called TidyUps, where they talk about potential ideas that they have for the Tidyverse, like this one, recoding and replacing values in the Tidyverse. It's completely open, and people are available to invited to write comments and feedback. Oh, I love this. Oh, I would reconsider this. Why is this? And so on. And the maintainers actually take a look at it to decide what they're going to work on next. And so, again, it's linked at the end of the slide deck. And if you find yourself really wanting to give input into the Tidyverse tools, please know that that is available to you. In addition to that, another way that community feedback is so important is this is my colleague Libby, who had written a post talking about this recode, like this recoding, options that we have in the Tidyverse. And so she wrote this post mentioning Erlang's triple bang operator with this exclamation point, exclamation point, exclamation point, and explaining how to use that to recode values. Because that was one way of doing it before the actual function recode values existed. And the maintainers saw this and were like, hey, this is incredibly complex for something that probably almost everybody has to do with dplyr all the time. And they took note of this, and because of this, this factored into their thinking about recode values and how that function should work. And so my request to everybody is, if you are finding yourself really having a tough time with your open source tools, or you've found yourself having a great time with your open source tools and you created something really cool, I just really highly encourage you to share it and post it and have others take a look at it, because this is how we all grow and how we all learn. And you never know, your next post might inspire what comes out in dplyr 1.3.0. So just in summary, all the things that we talked about today: use filter to keep rows, use filter out to drop rows, use when any for or logic in your filter statements, use when all for and logic in your filter statements, use recode values for anytime you find yourself using equal equals in case when, and use replace either when or values to modify existing columns in your data frame. And that's dplyr 1.2.0. You can upgrade today and give it a shot. I hope, again, these slides and the exercises are helpful, and thank you for joining us.
Okay, I believe at this point we don't have any more questions to attend to. So I would like to use this opportunity to say a big thank you to Isabella for joining us today. We really appreciate your time, and we really appreciate all what you've shared with us today. And I believe each and every one of us will try our hands on the new version of dplyr. Thank you so much. So, and to everyone who has taken their time to join us for this meetup, we appreciate your time. We appreciate your contributions, and we look forward to meeting you during our next meetup. Thank you.
Thank you so much.
Thank you.
Bye.
Bye.